I've got a stack of in-class quizzes to return to you. You've been getting the grades in your progress reports. The problem was I haven't been bringing them back to give to you, and this is my bad. Blackboard, because of the whole Blackboard issue we had at the beginning of the term, I started making a Blackboard pile. Because people were handing stuff in hard copy that wasn't in Blackboard. I was like, okay, I'm just going to put this here, grade it, and then deal with it. And then I started putting those out in my little window box by my office. Figured if people wanted them, they'd come pick them up. Then I started doing in-class quizzes, but inadvertently I put them in the same pile sometimes. My pile system failed me. Thursday, I will bring back everything I've got in that pile so we can actually root through that and get the stuff that you guys need to have back. You've been getting the grades, so the grades are fine, and you know how you're doing and everything, so that's fine. The problem, of course, is that I don't actually return those physical copies if we have them back to you, and I want to make sure I get those back to you. And I apologize for not. I realized it this morning as I walked by. I'm like, holy crap! This pile is now this big, which I never intended it to be because it's full of Blackboard stuff too. But your in-class quizzes got mixed in with those, and I want to get those back. I want to get those back to you guys. I have an in-class quiz for us to do today, which I guarantee will not be in that pile because I'll get it back to you on Thursday with everything else. So apologies for that. I'm totally sorry about that. How's your guys' Thanksgiving?
Wonderful.
We decimated the class. I apologize. My goodness. Yes, week 10. You've made it. It's almost over.
Shall we cheer?
Well, I guess. Some people are going to say not yet. That's okay. I think you should. Yes, we're there. Week 10. It's got to feel good, yes? Yeah. Except for the weather. Weather's a little weird. More like Salem than Bend, but whatever. Good? Other classes ended up okay?
Yeah.
Yeah. Okay, we'll stop talking about that, eh? We'll talk about numbers. We like numbers. So, let's see. What are we doing today? Today, we are doing... We're still in the bell curve, aren't we? Yes, we're still playing with the bell curve. We're playing with IQ questions. And my goal, I think... Up there. That should be okay. My goal for the remainder, we only have 2 days left, and rather than rush a bunch of stuff in the last 2 days, I want to kind of wrap up what we're doing here with the bell curve, and then rather than like rush in to get one more topic, there is technically, if you look at the syllabus, one more topic on the syllabus, and I'm realizing now that I don't want to just rush to get that topic in. I left that topic off your exam for next week in the belief that we might not get to it in here. And I think that's okay not to get to that topic. I'd rather just stay in this topic and make sure it makes a lot of sense rather than rush into some other one. So instead of rushing to that last one, I'd rather just finish this one up good. So the central limit theorem, how many of you guys are taking Math 244 at some point? A couple of you. Yeah, I will get you guys a resource. Well, I'm going to watch time. We might still be able to do the experiment in class. But I'd rather not, like I said, rush to get something in. I'd rather do one thing as well as deeply as we can rather than a bunch of things more shallowly. So let's get back into this. I forget exactly what we ended up with last time. Did we do the dull normal problem in class? Which was what percent of people were dull normal? Mm-hmm. Okay, did we get all the way to the end and actually figure out what percent it was? 16%. Good. Excellent. So 16% were dull normal. There was a lot to that problem, and it was a week ago, and I'm sure we've forgotten how to do it, which is totally fine. So we're going to start again. I have other ones set up here as well for us to play with. So, what was the big idea of being able to figure out the percent of people that were dull normal? What do we have to know to answer this question? With respect to IQ, what did we have to know?
Average.
Yep. You gotta know the average, which for IQ is 100. Beautiful. And what else do you have to know? There's a lot more curve besides just the average. Mm-hmm. What else you gotta know, Linda? Go ahead.
The standard deviation.
Which is 15. So for IQ, your average is 100, and your standard deviation is 15. Absolutely. And you got to know both those things, because that sets the curve up for you, and it gives you ranges to play with. So 15 up and down from 100 brings us to 115, brings us down to 85, brings us up to 130, brings us down to 70, and so forth. Keeps going as far as we needed to go. So yet last time, what we ended up doing was, we had to figure out dull normal, which was between 80 and 90. So it's that sliver of area right there. And we discovered that was about 16%. Okay, rather than redo that entire problem, because we have it on video, we did it last week, we'll do a new problem. But the idea is we have to convert that curve down to a corresponding curve, which is the standard normal curve. And this is the general normal for IQ. This is the IQ curve. What is the standard normal curve? What's he centered at? He's centered at 0. And what's the standard deviation on that guy? Plus or minus? Don't overthink this, just 1. It goes out to 1 standard deviation, or 2 standard deviations, or 3, or 4. It's the one that we've been playing with for a long time. Right. So the idea is moving back and forth between these two curves. That's all. Back and forth between those two curves. All you got to do is get off of the one you're on, onto the one you need, and generally the one you need is this guy. Oops, that should be a -2, I'm sorry. Sorry, friends. And that's why I gave you guys a program called Stonormal, because that allows you to go back and forth between one and the other. Fair enough? Believable? Ask me questions. If you have any questions to ask right now. Maybe you don't. You're still waking up. That's okay too. It's kind of a foggy day. Yes. Okay, so we had asked you guys last week, have you ever called anybody a moron, an idiot, or an imbecile? And we said yes. What I want to do now is I want to go back and calculate, because these have become part of our lexicon, yes? Moron, idiot, imbecile. There we go. Mean different things. They do IQ. Here we go. IQ scale. Today I found it out. I love this.com. All right, here we go. A moron is the highest level of intelligence for someone who is, oh, interesting. Those with an IQ between 0 and 25 are idiots, 26 and 50 are imbeciles, and 51 and 70 are morons. Let's calculate the percentage of that IQ level that's out in the general population. This was an IQ, removing any of the conversationalness of the word moron, like when you watch Bugs Bunny. What percentage of people have IQs between 51 and 70? Notice that 51 and 70 is an IQ percentage of 20 percentage points. 51 and 70, right? So if you look back to the PowerPoint 80 and 90 is 10 percentage points. And that was 16%, right? That was 16%. Can we just double that because it goes from 51 to 70? Is it that simple? What do you think? Is it that simple?
No.
Why?
Because the curve has more in the
right.
Close to the average.
The problem is when you take the curve out 100, 115, 85, 130, 70, 51's down here. We now have to find this area here. There's less area out in the tail than there is near the hump in the middle. Now the question is, it's too hard to do mathematically by drawing rectangles in it, because yes, there's 80 to 90 is here, which only covers this much area, but that area is very tall. This area almost looks like it's laying down and chunked off this way. But then again, that's just how I drew it. I mean, that depends on the fact that I drew this curve correctly, which I might not have done at all. So let's do this. Let's get this thing down to the Stonormal curve. Let's get this thing down to the Stonormal curve. 2. So we know this is -2. The question is, what's 51? What z-score does 51 occupy? Can we calculate it? Of course, this is the go-between. How do you get from the general scores down to the z-scores? How do you get from here down to here? What's the calculation? This is a week old, so you may have forgotten. That's totally fine. Linda, go ahead, help me out.
Isn't the formula gave us that use x for the 51, right?
Yeah.
Minus the average.
Over?
Standard deviation.
Yeah, that's the calculation. That's what you do. You take whatever number you have, subtract it from the average, then divide it by the standard deviation, and that moves you from one scale to the other. Fair enough? That moves you from one scale to the other. Fair enough? So now, that's how we got from 70 to -2. 70 minus 100 is -30, divided by 15 is negative 2. Boom. All we got to do now is figure out what it is for 51. So the z-score now is 51 minus 100 divided by 15, which is negative 49 over 15. And you can leave that as your z-score. You don't actually have to knock it down to a decimal. I wrote this program you can put fractions in as well. So somewhere around negative 3.5-ish, somewhere in there. Fair so far? So now we know
So
this. Go ahead.
do we leave it as a negative?
Why do you have to? What does the negative z-score imply?
So it's on the left side of the bell curve.
It's on the left side of the bell curve, it's below average. Yeah, so you want to leave it as negative. If you don't, it's going to look like it's over on this side, which is actually the other end of the bell curve above average. And you're going to get an area that's very close to 100% at that point. Which, again, you can get areas that are very close to 100%. But this particular IQ range occupies this part of the bell curve. Does that make sense, Linda? That's why the negative sign is important. The negative sign tells us it's below average. Fair? So now we've got ourselves two lockoffs. We've got ourselves negative 49/15, whatever that ends up being. Oops.
What was the 51 was for the particular?
This particular range, moron range, is 51 to 70. That's all. 51 to 70, boom, let's figure out the area between. Cool? Yeah, and that's the thing, John, these have to be given to you. I have to give you these ranges. In a second, we're going to give you a different parameter to work off of, but you have to know where to start, where to stop in order to get these guys knocked off. Cool? All right, here we go. I'm going to put this right here. All right. Oops, not coins. Is it forward or backward? This is a term we haven't used in a week.
Backward.
Why?
Below average.
No. because
Oh, careful. That's not what forward backward means.
That's we're not putting in the, whatever we're putting in the, it's forward because.
Okay, it's forward because we're not putting a percent in. It's up. And again, you got to realize, I named these terms forward and backward for class conversation. The question is, what are you putting in? If you're putting in the z-scores, it's a forward problem. If you're putting in an area, it's a backward problem. We're not putting in an area, we're actually looking for the area. Does that make sense? It's been a week, you've forgotten. That's okay. It's been a week, I totally get that. You had a lot of turkey. But since you're putting in the z-scores on the horizontal, it's a forwards problem. If you're putting in an area, which we'll do here momentarily, it becomes a backwards problem. Is that fair? Good, maybe. Let's see. Let's do it forwards. It's between. One thing you'll know it's not a backwards problem. If you try to put backwards, it won't give you a between option. I'm a bastard like that. You'll see why. Left bound is negative 49/15. Right bound is negative 2. It's going to shade for us. Negative 49/15 is down here, kind of off the range. You can't really see it. Negative 2 comes up right to here. What percent? About 2.2%. That's the percentage. That's how these IQ levels are set up. They pick the ranges to satisfy certain percentages. Why? I have no idea. I have no idea why the moron range is at 2.2. I got no idea. There's also a corresponding 2.2% on the other side. Linda, you mentioned it, didn't you? If you made that positive, it would be this guy out, so 130 up to roughly 151. That would also be a 2.2%. I don't know what that range is. This range isn't used anymore.
What was your right bound you used?
I use negative 2.
Negative 2?
Because that's the end of this scale, 51 to 70.
Okay.
Is that fair?
Okay.
Makes sense? So, and again, this goes back to Johnny's question, why 51? I'm just using the numbers they put on the scale, right? That's all I've done. I'm also not saying IQ measures anything. I'm not trying to get into that argument because we can get into an argument about that all day long, especially psychologists. I don't want to. I'm just saying because they were nice enough to give us an average of 100 and a standard deviation of 15, we are now allowed to put ourselves in a place to analyze those numbers, which is kind of nice. Fair? Please, Linda, go!
Okay, so we're that 2.2% of the population are more.
Between 51 and 70, exactly. And then, which used to be labeled moron back in the day, back in the 60s, yeah. Just like 16% of the population are dull normal. All those ranges, and if you look at the Wikipedia page for this, it's kind of staggering. The changing of the lingo over the past 50 years of IQ testing. They keep changing the names. Because some of them fall into common unfortunate usage. Like genius. The word genius now has a negative connotation. Well, you're a genius. Well, genius used to be, it used to be the highest level on the IQ scale. I think it was outside of 130. That was like considered genius. Now it's considered something like bright or overly bright or something like that. I mean, it's one of those things that just changes over time. I don't know why they're set that way. They just are set that way. Is that fair?
Yeah, I just want to make sure I know what this number means.
Oh, for sure. It's the percentage of people that are between 51 and 70. Just like there were 16, well, I erased it now. There were 16% of people between 80 and 90. Fair enough? Those are both forwards problems, though, because where did both of those problems start? You started by knowing what?
scores.
Good, good. Now, notice I didn't give you z-scores in the original problems. What did you have in the original problems? We converted the z-scores, right? Converted what to z-scores? Good, the IQ score itself was converted to a z-score. So these x's, Linda, you referred to them as x. I love that, you call them x's. You had these guys that we had to convert down to become this guy to feed into our table. Very, very, very good. So when you have the original scores that you do the conversion, then you end up with the z-score that you can then feed in. That's what makes it a forwards problem. So what would a backwards problem make? What would a backwards problem look like? Could you phrase one for me? For using IQ. Using IQ. Think about this. Think about this for a couple seconds. Let's swing over to the sideboard here. Think of a backwards